A new AI lets humanoid robots move and manipulate objects all at once. This unifies robot control, solving a critical challenge. Let's get into it. Let's start with a featured paper. Omega Zero, a latent predictive world action model for concurrent humanoid loco-manipulation. By Zhe Li from Mars Lab and TU. This paper presents a significant step towards unified humanoid control by integrating loco-manipulation into a single predictive model, addressing a critical challenge in robotics. Here's a full breakdown.
Let's begin with the overall architecture, which is a latent predictive world action model. It uses a joint video action latent predictor to understand the scene and then feeds this understanding into an action DIT to generate the final robot motion. Feeding into it, rather than predicting entire future video frames, the system generates a compact future video latent. This efficient representation, produced by the joint video action latent predictor, captures the necessary visual information for planning. Next, this latent visual foresight is coupled with a diffusion-based generation process to create the robot's movements. The action DIT takes the future prediction as a condition and denoys a random latent into a coherent whole-body latent. Finally, to ensure the generated actions are physically executable, the model's output is grounded through a controller. The whole-body latent is sent to the sonic controller, which translates it into the specific joint positions for the robot. The Omega Zero methods, particularly Omega Zero Omni, significantly outperform all other listed methods across success rate, score, and task progress. For instance, Omega Zero Omni achieves an 81.8% success rate and a 36.7 score, which are substantially higher than any prior approach.
Up next, our second paper out of 3, Hijacking Robots with a Piece of Paper, a systematic study of physical prompt injection in VLM-Controlled robots by S.M. Bhagia P., Samarakun and Mohan Rajesh Alera from Singapore University of Technology and Design. This paper identifies a critical and novel attack surface for VLM-controlled robots, demonstrating a practical and concerning vulnerability that will necessitate immediate attention from developers and researchers. Let's break down its key contributions.
We begin by identifying a new attack surface for robots that use vision language models, physical prompt injection. For example, a simple sign like final collection point placed in the environment can be misinterpreted by the robot as an instruction. To systematically study these attacks, we developed a taxonomy with 4 main categories. These are indirect signage, task redefinition, authority impersonation, and conflict injection. We then created a comprehensive benchmark of 20 attack prompts, from A1 to A20, to test system robustness. This benchmark also includes a neutral control prompt, have a nice day, to establish a baseline. Our evaluation reveals how these attacks succeed by targeting specific weaknesses in the models. For each attack, we identified the exploited vulnerability, such as rule replacement or system authority deference. Finally, we explored potential defenses against these physical prompt injections. We assessed several mitigation strategies, including prompt-based defenses and text masking, to understand how we can make these systems more robust. GPT-4o and Gemini 2.5 Flash consistently achieve high attack success rates, often reaching 100% on various attack IDs. In contrast, Qwen 3VL 32B generally shows a substantially lower attack success rate across most attack IDs.
Up next, our third paper out of 3, Reducing Belief in Conspiracy Theories as They Unfold Using Large Language Models by Thomas H. Costello and David G. Rand from Carnegie Mellon University. This paper presents a groundbreaking and timely empirical study demonstrating the potential of LLMs to mitigate belief in unfolding conspiracy theories, addressing a critical societal challenge with real-world experiments. Let's break down its key contributions.
Conspiracy theories often emerge rapidly following major societal events, posing a significant challenge to public understanding and trust. This phenomenon highlights a critical need for effective and scalable interventions that can address misinformation as it unfolds. This research aimed to explore whether large language models, or LLMs, could serve as a novel tool in this effort. Specifically, the study investigated if engaging in conversational dialogues with an LLM could help reduce individuals' belief in these emerging conspiracies. The researchers conducted 2 experiments involving U.S. adults who held conspiratorial views about recent crisis events. Participants were randomly assigned to engage in a multi-turn conversation with an LLM specifically designed to challenge their conspiracy beliefs. Control groups either discussed an irrelevant topic with an LLM or reviewed a static fact sheet. The primary outcome measured was the reduction in conspiracy beliefs, both immediately after the intervention and for downstream effects observed 1 to 2 months later.
Those were the top papers. Now, let's zoom out. ArXiv received 656 new computer science papers across 56 subfields today. Here are the trending areas shaping the field. Zooming out, the day's research clustered into 4 big themes: LLM reasoning and enterprise integration, advanced AI for generation, time, robust AI for critical decisions, bridging tech, humans, security. The full paper list is in the pinned comment below. That's all for today's ArXiv Computer Science Daily. If you found this helpful, please like, leave a comment, and subscribe for daily paper summaries. See you tomorrow. Thank you to ArXiv for use of its open access interoperability.